Hi guys, so we're going to take a look at question 3 from paper 2 of the 2015 exam. So the coordinates of 2 points are A, 4 minus 1 and B, 7t. A, 4 minus 1, B, 7t, always mark what's relevant. The line L1, which is 3x minus 4y minus 12, is perpendicular to AB. Perpendicular to AB. Find the value of t. Okay, well, what do we know? Well, we have A equals 4 minus 1. B equals 7t. Okay, so we don't know the y coordinate of B. And our line, let's call it L1, is 3x minus 4y minus 12. Oops, weird looking 2, equals 0. And they're perpendicular. Perpendicular to AB. To AB. Okay, well, what does it mean for a line to be perpendicular? Well, if two lines are perpendicular, oops, that's not how you spell perpendicular. Perpendicular, then the product of their slopes, is minus 1. Equals minus 1. Okay, well, what's the slope of A? Well, the slope of AB. Well, we have a formula for the slope. So if we have 2 points, then the slope of the line between them is m equals y2 minus y1, y2 minus y1 over x2 minus x1, the rise over the run. Alright, so in this case, it would be y2, so the y-coordinate of B, which is t, minus the y-coordinate of A, which is minus 1, so plus 1. Minus minus equals a plus. And then the x-coordinate of B, 7, minus the y-coordinate of A, which is 4. So t plus 1 over 3. 1 over 3. And now what is the y-coordinate, the slope of L1? Slope, so we have another formula for the slope. So if the equation of a line is written in that form, then the slope is m equals minus a over b, where a is the coefficient of x, b is the coefficient of y. So in this case, it is minus 3 over minus 4, so just 3 over 4. Okay, and now we want to find y. So we know the product of 3/4 and t plus 1 over 3 will be minus 1. So 3/4 by t plus 1 over 3 is top by top, bottom by bottom, or 3 and the 3 cancel, so we get t plus 1 over 4 equals minus 1. And then we just solve for t. It's just as simple as that. So we multiply both sides by 4, t plus 1 equals minus 4, and then bring the 1 over, so t equals minus 5. And that's our value for t. So find in terms of k the distance between the point P, which is 10k, and the line L1. So find in terms of k distance P10k and L1. Alright, well, we know that So let's just write down our line and our point. So L1 equals 3x minus 4y minus 12 equals 0. And our point equals 10k. Always good to just write down this information, refresh it, get it on the page, get those attempt marks. All right, and we actually have a formula for the distance from a point to the line. Remember, log tables is your absolute best friend. So let's write down that formula. And it's the magnitude of ax1 plus by1 plus c over the square root of a squared plus b squared. Oops. Okay. Let's call that our distance d. Okay, so in our case, a is 3, b equals minus 4, and c equals minus 12. And our x1 and y1, so x1 is the x-coordinate of p, which is 10, and y1 is the y-coordinate of p, which is k. So we're just going to plug this into our formula. Very nice and simple. 3 by 10 minus 4 by k plus c, so minus 12, magnitude of that is all over 3 squared plus 4 squared, which is just 5 squared. So let's actually just get rid of that, and it's just 5. 9 plus 16, 25, square root of 25 is 5. Okay, so let's put that into a calculator. So we get 30 minus 12, so 18 minus 4k. So 18 minus 4k over 5. Okay, well, we were asked to find, in terms of k, the distance between 2 points, and, well, we have it. The distance is the magnitude of 18 minus 4k over 5. Now, on to part C. P 10k, is on a bisector of the angles between the lines L1 and this L2. Find the possible values of k. Okay, well, let's just write down L1 again. 3x minus 4y minus 12 equals 0. L2 equals 5x plus 12y minus 20 equals 0. All right, so let's say our two lines look something like this. I don't know if they do, maybe they do. Then the bisectors of these lines, the bisectors of the angles of these lines would look something like that, or something like that. Something like those two. So those are the two possible bisectors. Okay? Well, what does it mean for K, so P to be on this line? Well, let's say P is somewhere like here. Well, we know that the distance from P to, let's call this L1, and the distance L2, we know that these are similar because it's on the bisector. Okay, so now we know that P is equidistant. So let's say P is equidistant from L1 and L2. And we actually have an expression for the distance from P to L1. So, and that's 18 minus 4k over 5. So, 18 minus 4k over 5 equals the distance from L1 to P. So it's also equal to the distance from P to L2. Well, we can actually get an expression for the distance from P to L2. And we can let these two things equal. So let's just give ourselves some more space. Okay, equals distance from L1 from P to L2. Distance. Actually, let's just call this D1 equals D1 equals D2. All right, so, and let's calculate D2, the distance from P to L2. D2 equals, using our formula again, let's put our formula in here. Always good to write down your formulas. If you get it wrong, they know you were using the right formula. AX plus BY1 plus C over the square root a squared plus b squared. Why does it always do that? Equals our distance. All right, okay, so in this case, a equals 5, b equals 12, c equals minus 20. C equals minus 20. And x1 equals 10, y1 equals k. All right, so let's just plug that in. So we get 5 by 10 plus 12 by k minus 20 all over the square root of 5 squared plus 12 squared, which is, I'm just going to stop doing that, which is 13 if anyone knows their Pythagorean triples. So if we plug that in, we will get 50 minus 20, so 30 plus 12k, we'll get 30 plus 12k all over 13. Okay, and this equals D2, and D2 equals D1. So we get that 18 minus 4k over 5 equals the magnitude of 30 plus 12k over 13. And then if we just multiply these cross by cross, we actually need more space. This is quite a long question. Let's see, put it there. So 13 by 18 minus 4k equals 5 by 30 plus 12k. Okay, so we could multiply inside the 13 inside and the 5 inside the absolute value, but it would just be the same thing as letting this be a plus or minus. So 13 by 18 minus 4k equals plus minus 5 by 30 plus 12k. All right, so then if we multiply this in, this is 234 minus 52k equals plus minus 150 plus 60k. All right, so if it's a plus, let's say if it's a plus, then let's bring the 52k over, and we get 84 equals 60k plus 52k is 112k. So k equals 84 over 112. K equals 84 over 112. And if it's a minus, we get 234. Bring the minus 150 over, so we'll get 384 equals, and then bring the 52k over to the minus 60k, and we'll get minus 8k. So k equals 384 over minus 8. And so if we just simplify, this is 3/4, and this, let's get rid of that. This equals minus 48. Okay, so if k is greater than 0, all right, so k is 3/4. If k is greater than 0, find the distance from P to L1. Okay, very nice. Very nice end to the question. Distance from P to L1. Okay, so we have k equals 3/4. We know that, so P equals 10 3/4. And well, we actually have our distance. We have a formula for the distance, so we don't even need to write down L1. So our formula for the distance, D1, is 18 minus 4k over 5. I should have written that in blue. It's my formula color. All right, so if we plug this in, we get 18 minus 4 by 3/4, which is just 3, over 5. So we're just going to get 15 over 5, which is 3. And it's as simple as that. Very nice end to the question. C part 1 is definitely the hardest part of this question. And the trick to figuring it out is realizing that if a line bisects the angles between two lines, then anything on that line, so anything on our dotted lines, will be equidistant from both lines.